Generative AI refers to a branch of artificial intelligence, AI, focused on creating systems that can generate new data resembling authentic samples from a given dataset. Unlike traditional AI systems that are designed for specific tasks like classification or prediction, generative AI models have the ability to produce original content such as images, texts, or music. These models learn patterns and structures from large datasets and then generate new content based on the learned characteristics. Popular techniques in generative AI include generative adversarial networks, GANs, variational autoencoders, VAEs, and autoregressive models. Generative AI has diverse applications across various fields, including image synthesis, text generation, music composition, and even drug discovery. Generative AI has a wide range of applications across various domains. For example, it can be used to generate realistic images for art and design, create personalized recommendations in e-commerce, generate human-like text for chatbots or language translation, compose music, and even assist in drug discovery by generating molecular structures. In summary, generative AI involves training models to understand and replicate the underlying patterns in data, enabling them to generate new, realistic samples that resemble the original dataset. Generative models are potent tools utilized to craft increasingly lifelike AI-generated faces. They draw insights from vast datasets of images, leveraging this knowledge to produce novel images. The process initiates with meticulous data collection, amassing a diverse array of human faces spanning various ages, genders, races, and ethnicities. Subsequently, these images undergo meticulous pre-processing to standardize their size and format, ensuring optimal learning conditions for the model. Once prepared, the model undergoes rigorous training, where it ingests the images to discern intricate patterns and relationships between pixels. Finally, post-training, the model is equipped to generate new images upon receiving a set of parameters that outline the desired image's characteristics. Through this iterative process, generative models continually refine their ability to produce authentic and diverse human-like faces. Generative AI, with its ability to generate new content based on existing data, has found wide-ranging applications across various industries. In healthcare, generative AI is revolutionizing diagnostics and treatment planning by synthesizing realistic medical images and patient data. These synthetic datasets enable the development and validation of AI algorithms for medical imaging, disease diagnosis, and personalized treatment planning. Moreover, generative AI aids in drug discovery by generating molecular structures and simulating chemical reactions, accelerating the development of new pharmaceuticals. In entertainment, generative AI powers virtual character creation, scene generation, and content creation tools for video games, movies, and digital media. By generating lifelike characters, environments, and special effects, generative AI enhances the immersive experience of entertainment products, captivating audiences, and pushing creative boundaries. In art, generative AI serves as a tool for artistic exploration and expression, enabling artists to generate novel visual and auditory artworks. Artists use generative AI to experiment with unconventional styles, techniques, and concepts, blurring the lines between human creativity and machine intelligence. Additionally, in e-commerce, generative AI drives personalized product recommendations, virtual try-on experiences, and content generation for product descriptions and reviews. By analyzing user data and preferences, generative AI tailors the shopping experience, leading to higher customer satisfaction and engagement. Overall, generative AI continues to reshape industries by fostering innovation, personalization, and efficiency across healthcare, entertainment, art, and e-commerce. Generative AI, a transformative technology, permeates diverse sectors, revolutionizing processes and experiences. In healthcare, it crafts synthetic medical data to refine diagnostic algorithms and predictive models, ultimately improving patient care. Entertainment harnesses generative AI to create lifelike virtual characters and immersive environments, enriching gaming and storytelling experiences. Art embraces these tools to push boundaries, generating novel visual and auditory expressions that challenge traditional notions of creativity. Meanwhile, e-commerce leverages generative AI to personalize recommendations and streamline virtual shopping experiences, enhancing customer engagement and satisfaction. Across these domains, generative AI catalyzes innovation, enabling new levels of personalization, creativity, and efficiency. Generative AI encompasses a diverse range of technologies that leverage machine learning to create new content, images, and experiences. ChatGPT, utilizing the generative pre-trained transformer model, excels in generating various forms of written content and engaging in natural language conversations. Midjourney, a fusion of large language models and diffusion models, can produce visually stunning images from text descriptions. Stable Diffusion, a deep learning model based on diffusion techniques, empowers users to generate images according to their preferences, with control over the model's behavior. Google Gemini, a generative AI chatbot built on large language models, offers versatile interaction capabilities, interpreting and responding to text, video, audio, and code inputs. These examples highlight the versatility and creativity of generative AI in generating diverse forms of content and enhancing user experiences across different domains. Large language models, LLMs, are advanced neural network architectures trained on extensive text datasets, exemplified by OpenAI's GPT-3 and Google's BERT, transforming natural language processing tasks by comprehending, generating, and manipulating human-like text with impressive accuracy. Diffusion models, also known as diffusers, constitute a category of generative models utilized for image generation, estimating the conditional likelihood of an image given noise and producing high-quality photorealistic images. Multimodal AI models, or multimodals, adeptly process and generate content across diverse modalities like text, images, audio, and video, exemplified by OpenAI's CLIP model, which comprehends images and text concurrently for tasks like image classification based on textual prompts. Llama 2, large language models for medical applications, is a specialized application of LLMs tailored for healthcare, assisting professionals with insights, automation, and diagnosis. LAVA, large language models for audiovisual applications, refers to LLMs designed for audiovisual tasks like speech recognition and image captioning, trained on multimodal datasets to understand and generate content across multiple modalities simultaneously. Generative Adversarial Networks, GANs, are a form of artificial intelligence architecture comprising two neural networks, the generator and the discriminator, trained simultaneously in a competitive manner. The generator fabricates new data samples, like images or text, while the discriminator endeavors to distinguish between genuine data samples and those crafted by the generator. Through this adversarial interplay, both networks refine their performance. Initially, the generator produces subpar fake samples, easily identified by the discriminator. Over time, the generator learns to generate more convincing samples, while the discriminator becomes adept at discerning real from fake. This dynamic drives iterative improvements in both networks. Ideally, the generator eventually attains proficiency in generating realistic samples that confound the discriminator, signifying convergence. For instance, in a scenario aiming to create lifelike cat images, a GAN trained on a dataset of real cat images would see the generator honing its ability to produce authentic-looking cat images, while the discriminator refines its discernment. Ultimately, the GAN achieves convergence, yielding highly plausible fake cat images that closely resemble real ones. Transformers are a class of deep learning models that have revolutionized natural language processing, NLP tasks. Unlike traditional recurrent neural networks, RNNs, and convolutional neural networks, CNNs, transformers leverage a self-attention mechanism to capture the relationships between words and input sequences. This self-attention mechanism allows the model to weigh the importance of each word in the context of the entire input sequence, enabling it to process long-range dependencies more effectively. Transformers typically consist of encoder and decoder layers, each comprising multiple self-attention heads and feed-forward neural networks. During training, the encoder processes the input sequence, while the decoder generates an output sequence based on the encoded representations. Transformers have demonstrated remarkable performance in various NLP applications, including language translation, text summarization, sentiment analysis, and question answering. For example, Google's BERT, bidirectional encoder representations from transformers, model has achieved state-of-the-art results in tasks such as natural language understanding, while OpenAI's GPT, generative pre-trained transformer, model, excels in generating coherent and contextually relevant text. In a basic GAN pipeline implemented using PyTorch, the initial step involves importing necessary libraries such as Torch, torch.nn, torch.optim, datasets, transforms, and data loader for data loading and pre-processing. Following this, the data is loaded and pre-processed, typically involving normalization or resizing to prepare it for training using the function like transforms.compose. Next, the generator and discriminator networks are constructed as classes or functions, where the generator generates fake samples and the discriminator distinguishes between real and fake samples. Loss functions and optimizers, often torch.optim.atom, are defined to optimize the models during training. The training loop iterates over epochs, alternately training the generator and discriminator networks. Finally, after training, new samples can be generated using the train generator for evaluation and visualization. You can create your own pipeline to generate text using a pre-trained LLM model. To begin, install the essential libraries for working with large language models, LLMs, such as Hugging Face's Transformers library, using package managers like pip or conda. Once installed, import the specific LLM model you wish to utilize from the Hugging Face Model Hub, which hosts a diverse array of pre-trained LLMs like GPT and BERT, via the from pre-train method provided by the Transformers library. Next, initialize a pipeline for interacting with the LLM model, streamlining its usage for various tasks like text generation or classification. With the pipeline ready, add your prompt or input text to generate responses or predictions from the model, examining the result returned by the model for generated text or predictions based on your input. Finally, explore the LLM model's capabilities by providing different prompts or inputs, such as generating code snippets by prompting the model with programming-related text. These steps encapsulate the process of engaging with LLMs, from installation to exploring their functionalities through various tasks and prompts. Congratulations on reaching another significant milestone in your journey to master one of the most captivating fields in artificial intelligence. Throughout this course, you've delved into the realm of generative AI, uncovering its vast potential and practical applications across diverse domains. From grasping foundational concepts to exploring advanced techniques, you've navigated the landscape of generative AI with enthusiasm and perseverance. However, true mastery of generative AI goes beyond theoretical understanding. It requires hands-on experimentation and problem-solving. As you continue on your path, embrace the opportunity to innovate and create. Remember, the journey of mastering generative AI is both exhilarating and fulfilling, and your commitment will undoubtedly lead to success in this dynamic and evolving field.